Unit 16. I mean, can you get happier than this? I'm not. I mean, this is it, man. Finishing it up. I got to be honest with you. I only did this because I think it's cool. 100% I think it's cool. So this is called the unit circle. And when I was growing up, way back when, yeah, back when I had hair, um, we used the unit circle to figure out values of sine, cosine, and tangent. So it was our calculator. Um, so it's just a shortcut. It's just a way to not make a mistake by putting wrong buttons into a calculator. And it's the way we used to do it. So I'm just going to share it with you. Take notes on what's going on. You don't need to draw this unit circle. If you print off the sheet, you'll have an access to it. If you enjoy using it, keep using it. It works for me, worked for me. It'll work for you if you want to. So the idea of a unit circle, just the whole idea, I think is just a very interesting idea. And what it is, the idea of a unit circle is that you take a circle, you place it on a graph, and you set the radius to be one. One anything, 1 mile, 1,000, whatever, but we're just going to call it one. And when you do that, notice what happens. Well, let me go definitions first. I'm sorry. I'm getting so excited. So let's talk about I'm going to use some words, unit circle, which I've already used. I'm going to use this idea of reference angle. I want to make sure you know what I'm talking about. So what a reference angle is, when I talk about a reference angle, it's the acute angle. So I'm not talking about bigger than 90. It's less than 90. So it's an acute angle, and it's I formed it by two rays. One of the rays is always going to be the x-axis, and it's going to be the nearest x-axis. And when I say that, it's either going to be the positive or negative side of the x-axis. So it's the reference angle is an acute angle formed by oops, I hit something here. Nope. Formed by the array and the nearest side of the x-axis. That's XIS. Okay, so here's what I mean. Here's my XY. These are, whoa, all of a sudden it got small. Okay, this is my x-axis. If I was measuring an angle here, I'll do it in red. If I'm measuring this angle here, I use the ray that I used to make the angle, and then to the nearest x-axis. So in this case, that makes it, that would be the reference angle. Whereas if I was coming out this direction here, I'd be going from this ray down to this section, because that would make a 90 or make this acute angle. Now it's positive and negative, so I could even come down and do it this direction, but now I'm talking about this angle, or I could even come down in this direction here, and then I'd be talking about this angle here. So it's always referring to, when I talk about the reference angle, the ray itself with the nearest x-axis. Okay, so unit circle, and I kind of described what that is, but really a unit circle is just a circle with a radius of 1. Unit 1, unit circle. Okay, so here's what happens, and this is the part that's very interesting. I told you that my sine, cosine, and tangents are ratios of right triangles. And the next thing I told you was that those ratios are consistent with similar triangles. It doesn't matter if the triangles are similar, then those ratios are equal. Now, we're making right triangles by the unit circle. So if you look at this example, I'm going to shrink it so you can get on the whole page. I know it's kind of small, but you'll be all right. So we've put a circle on the graph. This piece has a value of 1. That's why this intersection is at 1, 0. And what we're saying here is that we are making points on that unit circle at specific angles. So notice that I've labeled this as 30 degrees, and what that means is that this reference angle is 30 degrees. And it's sort of interesting, but this has a location, and the location is based upon this right triangle. Now the value I go across is my x value, and the value up is my y value. And if we think about what's going on here, remember SOHCAHTOA, sine of this angle is opposite over hypotenuse. Now what's happened on that unit circle is my hypotenuse is always 1 because that's this value here. Well, that value is going to be 1 no matter which of these angles I pick. So all this sine value is, it's my opposite. It's my y coordinate. So sine A actually has the value of my y in this point, or in this case, 1/2. Cosine, cosine of A is adjacent over hypotenuse. Now we just said the hypotenuse is 1, so really it's just the length of the adjacent, and adjacent is my x value. So in this case, my x value is square root of 3 over 2. So my x value represents my cosine, my y value represents my sine. So really what the unit circle is, it's a list of sines and cosines of angles. So I just want you to look at this for a moment, and it's kind of interesting. Actually, I'm going to also add up here that point, what I just said. Cosine are my x's, sine are my y values. So cosine and sine. Cosine is always the x value, sine is the y value. So here's how I used it in school. When I was asked a question, and we'll go through a couple of examples here, maybe I was asked the question of, what's the sine of 120? Okay, I'm going to come down here. I'm going to write down this question. Sine of 120. Now, currently we have a calculator. I can go to my calculator, type 120 sine, and it shoots out a value. But if I didn't have that, if I only had this access of this sheet of paper, I could go, fine, sine of 120, let's find that angle. Well, I'm looking here, and if I was going to look for 120, notice I'll pick a different color now. I'm going to go orange. 120, here's my 120 degrees. So I know that I'm talking about this angle. And they asked me for the sine, and I knew sine was the second value here, so it's square root of 3 over 2. So I can very quickly, not a problem, teacher, easy, square root of 3 over 2. And that's correct. That's the value of it. And so if I could do this with any question, any of these values that are listed on my unit circle are now accessible to me. So let's go through a couple of these. Let's go cosine of 225. Let's go tangent. When we get to it, I'll talk about it, of 315. Sine of 220. Cosine of 180. And tangent of 270. Okay, so let's look at cosine of 225. So I'm going to come up here. I'm going to look for that value of 225. And ding, 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 there's my 225. So cosine, I remind myself, oh, that's my x value. So this is my value here. So I just go, oh, negative square root of 2 over 2. So yeah, that's it. Negative square root of 2 over 2. So this is kind of, oh, this is so easy. What's the big deal? Well, it gets a little more in depth when we talk about tangent, because tangent's not listed here. Tangent is actually, remember we talked about TOA, it's opposite over adjacent. But the good news is I know what the opposite values are and I know what the adjacent values are. Tangent ends up becoming opposite. If you remember, opposite is sine, adjacent is cosine. So actually tangent is sine over cosine. So now I just need to, it's just a little extra step here. So tangent of 315, so let's go find that. 315, ding, 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 ding. All right, so sine is this value. So I got negative square root of 2 over 2. And sine is square root of 2 over 2. Well, they're the same thing. So the value is anything over itself is 1. And since you have a negative over a positive, it's negative 1. Well, that's not as hard as I thought it was going to be. All right, looking at the next, sine of 220. Sine is the y value, 220. What? That's not even there. Why would I pick that one? Well, let's guess. Okay, well, 220 sine is the y value, negative square root of 2 over 2. That's a good guess. Because look how close it is. 225 and I said 220. I think I meant to say 270. Let me change that from 220 to 270. But our guess would have been pretty dang close, wouldn't it have? But anyway, if you say 270, I can go, hey, look, 270. Sine is this value, negative 1. Cosine of 180, here's my 180. Cosine is my x value. Hey, that's negative 1 too. Tangent of 270, so this is what this one is. So sine over cosine, negative 1 over 0. Well, anything over 0 is 0. All right. Thank you for being patient with me and let me talk about something that I think is kind of interesting and cool. But just so you know, this is how your parents did it. This is how we figured out sines, cosines, and tangents. Is we had to do it from a unit circle. Not that hard, but just different. Anyway, have a great day. Reach out if you have any questions. Ask me questions via email or phone, or come by and see me. Have a great day.